welcome to today's lecture. The lecture series that I am covering is for the subject embedded system. Subject code is KOE 062, that is open elective. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am covering today is Serial Peripheral Interface, that is SPI. That is a serial communication protocol. Let us go into details. When we talk about the SPI, that means Serial Peripheral Interface. As the term is already defining, it is the serial communication protocol and it is synchronous. That means there must be some clock used in the system. Used for short distance communication. This interface was developed by Motorola in 1980. SPI devices communicate in full duplex mode. What is this mode? We have already discussed that the full duplex, half duplex, what are these modes? In the full duplex mode, the communication between the sender and the receiver can take place simultaneously. This is the two-way communication and it can be done at a same time. In the half duplex mode, two-way communication can take place, but one at a time, means either the sender will be sending some data or the receiver will be sending, receiver side will be sending some data, but the transmission from both the sides cannot be done at the same time. That is the rule of half duplex communication. And in the simplex mode, none is possible, means there is only one way communication, that the data will be transmitted from one side to other only. So, when we are talking about SPI, this is full duplex mode, because it is having the multiple lines for the data transmission from either side. We will see in the further slides how is it possible using a master slave architecture with the single master. So, in this there is a master slave architecture where the single master is only available. The master device originates the frame for reading and writing. Multiple slave devices are supported through selection with the individual slave select line. This is very important point. There are slave select lines using which the slave device is selected. Unique feature of SPI includes that data can be transferred without interruption. We will see how is it possible. These were the certain features of this SPI protocol. Any number of bits can be sent or received in the continuous stream, obviously. This is the serial communication. So, any number of bits can be transmitted. In SPI, only one side generates the clock signal, and what is that one side? That is the master side. That side generates the clock is called the master and the other side is known as the slave. The master is the controlling device, usually a microcontroller. So, when we are talking about this SPI, we are talking about in reference to the embedded system, since we are studying that subject. So, when we are talking about the communication protocols in the embedded system, obviously one of the device will be some processor or the controller. So, here the master device will be microcontroller, while the slave device will be other peripherals, which may include the sensor, display or the memory chip, which are taking the instructions from the master device. So, in this way the communication is set up between the microcontroller or the processor and the other peripheral devices in this SPI protocol. Now, this is these are the technical points about the SPI. So, SPI signals, there are 4 logic signals, SCLK, that is the serial clock, and this serial clock is originated from the master, it is sent from the master. Another important signal is MOSI, MOSI, that is master output slave input. Means this line will carry the data from the master side to the slave side, that is the data will be the output from the master and input to the slave. So, this is the master out slave in. Now, another important line is MISO, that is master input slave output or the master in slave out, that is the data will be transferred from the slave side to the master side, that is slave will be treated as the output and master will be treated as the input device. This is MISO. Now, last line, last signal but very important signal, that is the slave select signal, and it is active low. We have to note that this is active low, output from the master. What is this slave select? This is the line, this is the signal which is used to select the desired slave. How? When the multiple slaves are connected to the master, then the signal sent on this line activates the particular slave. So, when we are talking about this system, this is the master, this is the slave. On the master side, there are 4 signals: MOSI, MISO, S clock and signal slave select or chip select. CS stands for chip select. And on the slave side, there is MOSI, MISO, S clock and again slave select or chip select. So, in this way, both the devices are having the same signals. Let us go into details of these signals: serial clock signal, S clock or slave select signal. SPI is a synchronous communication protocol. The signal, the clock signal synchronizes the output of the data bits from the master with the sampling of bits by the slave. So, in this way the clock signal works. 1 bit of data is transferred in each clock cycle, it is obviously known. So, the speed of the data transfer is determined by the frequency of the clock signal. This is very important. In this case, the frequency of the clock signal determines the speed of the transmission. SPI communication is always initiated by the master, since the master generates and configures the clock signal. So, here the master is the only device which is generating the clock signal, which is configuring the clock signal. So, this is the controlling device. Master can choose which slave it wants to communicate, yes, but how? Suppose the master wants to select a particular slave. So, the SS line which is connected to that slave, the master will send the low signal on that particular line to activate it. So, in this way the master selects the particular slave it desires. In the idle non-transmitting state, the slave select line is kept at the high voltage level. So, in this way slave select line is used. Now, SPI configurations. So, and what about these MISO and MOSI lines? We have already discussed that MOSI line is used to transfer the data from the master to the slave side, and MISO line is used to transfer the data from the slave to the send the data from the slave to the master side. So, in this way the MOSI and the MISO, these are 2 lines which are useful in achieving the full duplex communication. As we have already discussed in the features of SPI, that it is the full duplex communication system. So, the existence of this MOSI and MISO determines the full duplex mode. When we talk about the SPI configurations, so multiple CS or SS pins may be available on the master, which allows for multiple slaves to be wired in the parallel. Okay. So, as we are looking in this in this picture, that there are multiple slaves. Here also there are multiple slaves. There are 2 ways of connecting the multiple slaves. How? If only one, if the multiple CS or SS pins are available, or if only one CS SS pin is available. So, in this figure we can see that there are multiple slave select pins available. So, how it works? Obviously, the multiple slaves can be selected by sending the active low pin active low signal on the particular slave select line. So, in this way the multiple slaves can be selected. In this case, how the multiple slaves are used? By using the daisy chaining system. What is this daisy chaining system? It is a priority based system. Interrupts are generated based on the priority of these slaves. So, the priority is already decided for each of the slave, and according to the priority, the slave, that particular slave generates the interrupt signal, and hence it can be connected to the master device. So, in this way the daisy chaining system is it's one of the protocol daisy chaining. So, using this daisy chaining scheme, the multiple slave devices can be connected to the single master. So, these are two configurations, either having the multiple slave select lines or having the single slave select line, but using the daisy chaining scheme the multiple slaves can be connected. Let us understand this protocol step by step. First of all, the master outputs the clock signal. This is the clock signal. The master sends the clock signal to the slave device using the S clock line. The master switches the CS or SS pin to a low voltage state which activates the slave. So, here this was the clock signal which was being sent from the S clock line of master to the slave S clock line of slave. Now, here the low signal, this we can see that this is the active low signal, it is being sent from the chip select line of master to the chip select line of slave. So, in this way that particular slave is activated. Now, the master sends the data one bit at a time to the slave along the MOSI line, master out slave in. So, obviously, if the master wants to send the data to the slave, so it will send the data on MOSI, that is master out slave in line. So, this is the data, and while transmitting the data we have to note that the last bit which is here, this is the MSB. So, the MSB bit is sent first and then the next bits. So, in this way when we if we are reading the data from the MSB side, then it is 0 1 0 0 0 0 1 1. So, this is the data. Now, if the response is needed, suppose now the slave wants to communicate with the master sending some data. So, the slave returns the data one bit at a time to the master along the which line, not on the same line, since this is the half duplex this is the full duplex communication system. So, obviously, there are two different lines, one is the MOSI and another one is the MISO. So, the data from the slave to the master side is sent using which line? Using MISO line. So, we can see that the slave is sending the data using this MISO line, and this is the data. Here LSB will be sent first. On the previous step MSB was sent first, and here the LSB is sent first. So, if we read the data from the master by bit, that is the most significant bit, then it will be 0 1 0 0 0 0 1 1. So, in this way the transmission completes. Here there is one important point, that the transmission between the sender and the receiver takes place using the shift register. So, here are two shift registers in each of the devices of some given word size, maybe 8 bits, one in the master and another one in the slave. They are connected in a virtual ring topology. Data is usually shifted out with the most significant bit first. Yes. On the clock edge, both the master and the slave shift out a bit and output it on the transmission line to the counterpart. So, in this way the clock is sent from the master to the slave, and master out slave in line carries the data from the master to the slave side. These are the shift registers, and in this the bits are sent one by one. So, here the most significant bit, that is we can say this is the most significant bit, this is transferred first and then the next bits. So, in this way this bit is sent and this is shifted then again this bit comes here. So, in this way using the shift registers in both the devices, this transmission completes. On the next clock edge at each receiver, the bit is sampled from the transmission line and set as a new least significant bit of the shift register. As I have already discussed that this MSB will be shifted and will go to the least significant side, and again the process repeats. After the register bits have been shifted out and in the master and the slave have exchanged the register values. Now, if more data needs to be exchanged, the shift registers are reloaded and the process repeats. So, the shift register plays a very important role in the data transmission in case of SPI communication protocol. Transmission may continue for any number of clock cycles. So this is another very important factor, and it is the advantage that the transmission may continue up to any number of bits and up to any clock cycles. When complete, the master stops toggling the clock signal and typically they deselects the slave. What is this? As you can remember that before starting the transmission, the clock signal was the first signal that was sent from the master to the slave side. And what was that clock signal? A toggling signal 0 1 0 1 0 1, that is the toggling signal. So, if the master wants to stop this transmission, then what will it do? It will obviously stop the clock. So, the first thing the master will do for stopping the transmission is that it will stop sending the clock signal, that is it will stop sending the toggling signal. So, here the clock signal is given another name, that is the toggling signal, and typically deselect the slave, and another thing it will do is to deselect the slave. So, obviously the second step during the transmission was to select the slave to which it wants to communicate, it wants to send the data. So, it will for stopping the transmission, it will obviously deselect the slave. When we talk about the advantages of SPI, it is a full duplex since there are two separate lines MOSI and MISO available for the data transmission, and data can be transferred simultaneously on both the lines. So, that is the full duplex mode. Push pull drivers. What is these push pull drivers? Here the pull up registers, or we can say the push pull drivers, are available in the SPI protocol. The lines can be connected using the push pull registers, and the advantage of that is that it will not limit the slew rate, and that is why the speed increases. So, here it leads to the high speed and good signal integrity. So, since the speed is high, signal integrity is good, then higher throughput can be achieved in case of SPI as compared to I2C or SM bus. What is I2C? I2C is inter-integrated circuits, that is another communication, serial communication protocol, and similarly SM bus, that is the system management bus, is another important communication protocol, and according to this point the SPI can achieve high throughput as compared to I2C and SM bus. Now, another point is it is not limited to any maximum clock speed, enabling the potentially high speed. Yes, this is very good point. The higher speeds can be achieved using this protocol. It is not limited to 8-bit words, means the higher bits, higher words can be transmitted using this protocol. Slaves use the master's clock and do not need precision oscillators, since in this scheme a master clock is used and this clock is generated by the master device. So, the slave works according to that clock only, and there is no need of adding other precision oscillators in this scheme. So, in this way slaves use the master clock and does not need the precision oscillators, and hence it reduces the hardware, it saves the hardware, and that is why this scheme is quite satisfactory and quite easy to implement. Slaves do not need a unique address. Yes, this is very important point. Unlike I2C or GPIB or SCSI. What is this GPIB or SCSI? That is a general purpose interface bus, and this is another system which is used to establish the communication between the computers, between the PCs and the peripheral devices. All these GPIB, SCSI, SM bus, these are used to establish the communication between the computer system, between the PC and the peripheral devices. Now, when we come to this point, slaves do not need a unique address. What does this mean? That in the case of I2C, we use some addressing scheme. Why? Because there is no slave select line to select the slaves. So, in that case, some address has to be generated. That address bits have to be added to the data bits, and in that way it is a overhead to the data. But in this scheme, in the SPI, there is no need of such addressing, since we are having the slave select lines. Simply sending a slow signal on the slave select line selects the slave device. So, it is a very easy process and there is no need for unique addressing. Now, when we talk about the limitations, we can easily see that it requires more number of pins. Since we have to achieve the full duplex mode, we have to achieve the simple selection process of slave devices. So, we are using the more number of wires. So, this requires more pins on IC packages as compared to I2C. No hardware flow control by the slave, but the master can delay the clock edge to slow the transfer. So, there is no hardware flow control from the slave side. Slave cannot control any flow process, but the master can control using the by changing the clock. By introducing the delay. So, in this way, so the flow control can be done using the master only. No hardware slave acknowledgement. Yes, this is another point. In case of I2C, we will see in the next lecture that in case of I2C, acknowledgement bits are received from the receiver side. So, that confirms the successful transmission of the data, but in this case there is no such acknowledgement. This is also an issue. So, the master could be transmitting to nowhere and we do not know it. So, this can be an issue. Typically supports only one master device, it depends on the device hardware implementation. So, it supports only one master device, but in case of I2C we will see that we can connect multiple masters. So, this is also the limitation of SPI. No error checking protocol is defined. There is no such error checking bit, but in I2C there was the parity bit which can be introduced to have the error checking system. But in the case of SPI we are not having any error checking system. So, these are certain limitations, and in the subsequent lectures we will see how the other protocols are having the advantages over this protocol. So, in the next lecture we will talk about the I2C. Applications include, it is used in variety of peripherals like sensors, temperature sensors, pressure, ADC, touch screens, video game controllers, control devices like audio codecs, digital potentiometers, DAC. In interfacing the memory it can be used like flash and EEPROM memory. In the real time clocks interfacing it is used in LCD. Sometimes even for managing image data it is used. Any MMC or SD card, that is the multimedia card or SD cards, these can be connected using this SPI protocol. Thank you. So, this was all about the SPI communication protocol. In the next lecture we will talk about the I2C communication protocol. Thank you.